Welcome back. In this last part of the lecture, we're going to talk about solving equations that have inverse trig functions. The first step to solving those kinds of equations would be to first isolate your inverse trig function. And once you've done that, remind yourself about the range of your inverse trig function, because it's possible that your equation might not have solutions because the value you're looking at is not a value that's inside your range. So, for example, if you had the equation sine inverse of x equal to pi, you know that there would be no solutions because sine inverse only has output between negative pi over 2 and pi over 2. That sine inverse of x never has pi as a value that comes out of it. So that means sine inverse x equals to pi would have no solution. Now, if you did have a solution, or if you know rather that the value that you're looking at is in the range of your function, then you can take your equation and rewrite it as a trig equation. Just like how we took an exponential equation and rewrote it as a log equation, switching inputs and outputs, we can do the same thing with taking an inverse trig equation and rewriting it as a trig equation. So for example, if you had sine inverse of x equals to a, then you could rewrite that as sine of a equals to x. And then now all you need to do is just evaluate that trig function, find out what exactly is the exact value. It's possible that you might need to do some sort of a substitution if you're looking at something where it's an inverse trig function where the input isn't just x. So for example, something like sine inverse of 3x. So in that sort of a case, you can do a substitution to make your life a little bit easier. You could say, well, let's replace u with 3x. And so then you'd be solving sine inverse of u equals to 1. Now the one thing, of course, just like the other times we've done substitution, don't forget that you have to undo your substitution at the very end. So once you find out what your value for u is, you'll need to go back and figure out what the value for x needs to be. So for something like this, we're looking at 18 tangent inverse minus 6 pi equals to 0. And I first start off by rewriting this as 18 tangent inverse x equals 6 pi. Divide by 18 so that I've isolated that inverse trig function. In this case, I've now got tangent inverse x equals 6 pi over 18. And that's the same thing as pi over 3. Now, the pi over 3, this is definitely something that is in the range of tangent inverse. So we do have a solution, and we can find our solution by rewriting the equation as a trig equation. So instead of tangent inverse of x equals pi over 3, we can say tangent of pi over 3 equals x. Again, switching inputs and outputs. That's the whole idea of how inverse functions can help us out. And at this point, now to find tangent of pi over 3, we just need to make use of our special triangle. And in this case, I'm using my 30, 60, 90 triangle. And tangent of pi over 3 is opposite over adjacent, which in this case, root 3 over 1. So x should just be root 3 over 1 or root 3. So my solution for this equation, just root 3. And we'll solve this one in the same sort of way. I'm going to first start by isolating my inverse sine function. So I'll move the pi to the other side. 3 sine inverse of 2x equals pi. And then I'll divide everybody by -3 so that I'll have sine inverse of 2x is negative pi over 3. And next, I'm going to do a little substitution here. Since I'm not looking at sine inverse of x, I'm looking at sine inverse of 2x. So to help myself out, I'll do a little substitution, replacing the 2x with u, so that we've got sine inverse of u equals to negative pi over 3. And I know that we're going to have a solution here because negative pi over 3, that is in the range of sine inverse. So yes, we are good to go. I can rewrite this as a sine equation. Instead of sine inverse, I'll have sine. And again, switching my inputs and my outputs. So u should be sine of negative pi over 3, which if you're feeling kind of clever, you can use the odd property of sine to help you out there. That's negative of sine pi over 3. And using the special triangle that we just had, sine of pi over 3 is opposite over adjacent, should be root 3 over 2. So that means that u should be negative root 3 over 2. Of course, don't forget that that's the value for u. We want to know what the value for x is. And so if u is negative root 3 over 2, and u is the same thing as 2x, then that means that x is negative root 3 over 4. And there we go. That would be the solution to this equation. All right, let's do one more here. We've got negative 4 cos inverse of 7 pi, and that is cos inverse of x equals to negative 7 pi over 4. And at this point, I'm going to stop because, again, we have to ask ourselves whether negative 7 pi over 4 is in the range of cosine inverse, and it's not. So since it's not in the range, since 7 pi over 4 is not in the range of cosine inverse, then there's no solution. And that's one place where we do need to be a little bit careful here, because if you didn't check your work here and didn't check to see whether or not negative 7 pi over 4 was in the range, you might be tempted to just start by rewriting this as a cosine equation and then coming up with a value for x. And you would be able to. That certainly is something you can find the value of. You can find the value of cosine of 7 pi over 4. However, that value that you find would not be a solution to the original equation. And the reason it wouldn't be a solution is we know that no matter what value we put in for cosine inverse, we're going to get out some value that's between 0 and pi. And that number, negative 7 pi over 4, is not between 0 and pi, which means that there is no value of x that will give you that output. In other words, there's no solution. And so that's where we do need to be a little bit careful, because we can fool ourselves into thinking that we found a solution. And in this case, if you did find out what is cosine of negative 7 pi over 4, that solution would actually be extraneous. It does not solve the original equation. So no solutions here. All right, last one for me to work through. And here I'm actually going to start out doing my substitution before I do anything else, just so I have a little bit less writing to do. I'm going to replace the x minus 3 over 2 with u, so that we've got 6 sine inverse of u equals to pi, or sine inverse of u is pi over 6. And pi over 6, that definitely is in the range for sine inverse, so we will have an answer here. We can say that sine of pi over 6 should be u. And again, using your special triangle, you can find that sine of pi over 6 is a half. So u should be 1/2. And now, going backwards, we know what u is. U is x minus 3 over 2. And so we can solve and find out that x should be 4. So if you have a value of 4 for x, and we put this into the original equation, it should make left side and right side equal to each other. In other words, we found that 4 is the solution to this equation.